Welcome to O-Level Chemistry. This is Naureen Najam and our today's topic is atomic structure. Hello students, today we are going to discuss atomic structure. The very first thing we should know about it is definition of atom. What is an atom? Atom is the smallest component of an element having the chemical properties of the element. Atom is the smallest particle of any element. Any element we know from periodic table. Basic structure of atom. The subatomic particles of atoms are electron, protons, and neutrons. You can see here the central heavy mass, this. This is called nucleus. Nucleus is the house of proton and neutron, means protons and neutrons resides inside the nucleus. And these circles are shells. These red dots are electrons. Electrons revolve around the nucleus. These shells are also called energy levels. So, how can we explain this whole diagram? An atom has a nucleus at the center containing protons and neutrons with one or more electrons circulating around the nucleus. Okay, in electron shells or at different energy levels. Now we'll talk about the charge. Proton has positive charge and neutron has negative charge. It means the overall charge for the nucleus should be positive. How? Let's suppose 2 plus 0. 2 protons. Okay, the charge plus 2 for proton and 0 charge for neutron. So answer should be plus 2, right? Just like that, 3 plus 0 is 3. The overall charge will be positive. That means that neutrons have 0 charge. Protons are positively charged particles. Neutrons have no charge and electrons are negatively charged particles. Like there are 3 protons in an atom. It means that there will be 3 electrons. It means that number of protons should always be equals to number of electrons in an atom. If there are 3 protons, it means that there should be 3 electrons as well. So plus 3 minus 3 cancel out. If I'll ask you that what should be the overall charge of atom, what should be the answer? 0. Let me give you another example. If there are 4 protons, it means that there should be 4 electrons as well. Plus 4 minus 4 cancel out each other. The answer will be 0. So can we say that the overall charge on atom is neutral, 0, because the number of positive charges are always equals to number of negative charges. Protons are positively charged, neutrons have no charge, and electrons are negatively charged. So the electrons are held by an electrostatic force of attraction by its negative charge and positive charge of proton. So an atom is electrically neutral. Now do you understand how atom is electrically neutral? Because of same number of positive and negative charges. Okay, so overall charge of atom should be neutral, means 0, because the same proton number, positive charge in the nucleus is balanced by electron number, negative charge in the shells. Now, how to identify atoms of different elements? The proton numbers, also called atomic number. Okay, proton numbers, also called atomic number in periodic table, atoms, all elements are arranged according to their increasing atomic number. Atomic number is also called proton number. So atomic number, proton number determines the identity of an element, just like roll number, class roll number. Each element has different proton number, and no two different elements have the same proton number. It is impossible. If proton number of hydrogen is 1 and proton number of carbon is 6, then there is no chance that someday they will be having same proton number. No, this is impossible. Now, for example, hydrogen has 1 proton number, carbon has 6 proton number, chlorine has 17 proton number. All right, that's what I'm talking about here. You can see this, the atomic structure of hydrogen. All right, atomic structure of hydrogen. Proton number of hydrogen is 1. Means proton number is 1. So electron will also be 1. Because number of protons should always be equal to number of electron. So the both will be same. Here in a shell, you can see 1 electron. It's revolving around the nucleus. 1 proton, 1 electron. This is the structure of hydrogen. Another example is carbon. Carbon has 6 proton. All right, carbon has 6 proton number. So carbon 6 proton number means 6 proton, 6 electrons. In first shell, there are 2 electrons. Why there are 2 electrons in first shell? Why not 6 electron? Why not 4 electron? We will discuss it later. First, just try to understand that there should be 6 electrons. 2 are in first shell and 4 are in second shell. 2 electrons in first shell, 4 electrons in second shell. Overall, 6 electrons and 6 proton and 6 neutron. But it doesn't mean that this is the rule that number of protons should always be equals to number of neutron. No, this is not the rule. The rule is number of protons should always be equals to number of electron. Okay, this is the rule. Let's see another example. Chlorine. Chlorine has 17 proton number. 17 proton number, chlorine means number of proton is 17. Number of electron is also 17. In first shell, you can see 2 electrons. In second shell, you can see 8 electrons. How? We will discuss it later. In third shell, we can see 7 electrons. 1, 2, 3, 4, 5, 6, 7. Okay, let's count the second shell. 1, 2, 3, 4, 5, 6, 7, 8. 8, 7. And in first shell, there are 2 electrons. 2 plus 8, 10, and 7, 17. Means there are overall 17 electrons in the shells, 17 protons, and 18 neutrons. All right. This time you can see that number of neutron is different. That's why I was telling you that there is no rule that number of protons should be equal to number of neutron. All right. This is a periodic table. Here you can see that in the periodic table, the elements are arranged in order of increasing atomic number. 1, helium 2, 3, 4, 5 boron, 6 carbon, 7 nitrogen, 8 oxygen, fluorine is 9, neon is 10, then here 11. Okay. Order of increasing atomic number, all elements are arranged. We'll provide you this periodic table in exam as well. Now what we'll have to do, first we need to understand the relative charges and approximate relative masses of protons, neutrons, and electrons. Since an atom is too light to be measured with a weighing scale, so relative atomic masses is used. Children, AMU means atomic mass unit and symbol is AR. AR means relative atomic mass. What is relative atomic mass? It is the average mass of atom of an element relative to the mass of an atom of carbon-12. Means one atomic mass unit, 1 AMU is equals to 1 by 12 the mass of carbon-12 atom. Suppose the relative mass of carbon-12 is 12. 6 proton plus 6 neutron. Okay, relative mass number. Mass number means we are talking about nucleus. We are talking about nucleus where protons and neutrons live. These are shells. Okay, here we are talking about this area. This area will give you atomic mass or mass number. This area will give you mass number. We can also call it atomic mass, relative atomic mass, or mass number, or nucleon number. All right. These three names we can use for this term. Relative atomic mass. So relative mass number of carbon-12 is 12. You can see here. See, this is carbon. This is the mass of carbon-12 and this is proton number 6. Okay. Mass number 12 means it has 6 protons and 6 neutrons. Relative mass of hydrogen is 1, means 1 proton and 0 neutron. Meaning the average mass of a hydrogen atom is 1 by 12. Means we are comparing the mass of hydrogen with carbon-12. Okay, we are comparing the mass of hydrogen atom with carbon. So the average mass of hydrogen atom is 1 by 12 of the mass of carbon-12 atom. The relative mass of a magnesium atom, another example, magnesium atom. Let's check it from periodic table. Here is magnesium. Mass is 24 and its proton number is 12. Here you can see this. All right. Mass is 24. 24 means proton plus neutron. Okay. Now we don't know how to determine the number of a neutron right now, but we know that this is proton. So this is proton. It should be 12, 12. All right. This is proton number. This is 12. So here the proton number should also be 12. All right. So we don't know the number of neutron here, but we know the mass number 24. I guess this is making sense. 24 minus 12. If we will subtract the number of proton from this value, then neutron left. That is 12. Here, let's check. Yes, the relative mass of magnesium atom is 24, means 12 protons and 12 neutrons. So meaning the average mass of a magnesium atom is twice the mass of carbon-12 atom. Oh, that's great. In fact, the relative mass of an atom or the total number of protons and neutrons in the nucleus. So electrons are omitted because their mass is so tiny. Now, a proton and a neutron weigh almost the same with a relative mass of 1. Here you can see relative mass is 1 for proton, for neutron, not for electron. That is negligible. But we used to write it as 1 by 1837 or 1 by 1840 sometimes. The charge you can see proton plus 1, neutron 0, electron 1. And the symbols are P, N, and small e with negative charge. For electron, protons and neutrons are in the nucleus of the atom. All right. So they are called nucleon. So what I was telling you at the time, that nucleon number, you can call it nucleon number. You can call it mass number. You can use the term atomic mass. 3 of them tell you one thing, that is number of proton plus number of neutrons. One meaning number of proton plus number of neutron, because nucleus is the home for proton and neutrons only, not for electrons. Now here the situation is the proton number. You can see this is the symbol. This is the symbol, any element. Let's suppose carbon. Okay. Number of nucleon in a nucleus is A. That is 12. You can see this. from periodic table, and atomic number of proton is Z. That is 6. This is a situation. The symbol for carbon is 6. Mass number or nucleon number or atomic mass is 12. And here, this is atomic number. We can call it proton number. Let's take another example. Sodium. The symbol for sodium is Na. Its mass number is 23. And its proton number is 11. Let's take another example. Nitrogen. Mass number is 14. And proton number is 7. All right. C. Atomic structure of hydrogen element. 1, 1. 1 proton means 1 electron. And 1 proton means no neutron. All right. Here is also 1. It means 1 proton. Means no neutron left. Means there are 0 neutron in hydrogen atom. Let's take another example. Helium. See, the mass number of helium is 4 and proton number of helium is 2. Can you tell me the number of neutron? Proton number is 2. Mass number is 4. Neutron number, I don't know. So can I say that if I subtract mass number from proton number, the answer will be 2. The number of neutron will be 2. Yes, I can say this. This number lets us know how many protons there are in a neutral atom. This is also the same as the number of electrons, and we can calculate the number of neutrons from it. See, this is the situation for first 20 elements: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, till calcium. These are the symbols. Atomic number or proton numbers, electron number. These are nuclear number. If I'll ask you, okay, I'm not showing this, I'm not showing this, I'm not showing this. If I'll ask you to calculate the number of neutron, can you do this? Like 1 mass number and 1 proton number. Answer. C. Yes, correct. Another one, mass number, proton number, 2. Oh, yes, correcto. 7, mass number minus proton number, 4. Correct. All right, I hope you got this and grasp all the idea related to this, how to calculate a number of neutron. This is your exercise. Before doing the electronic configuration, proceeding to lecture 2, you should know this. What is the name, mass number, atomic number, and neutron number of the following element? C6, 12. All right. H11, C8, 40, 20. Thank you so much. I hope you got the concept, and we will continue with the electronic configuration and do practice of the previous table. Erase all the number of neutrons and try to calculate the number of neutrons for this table. Thank you so much. Have a great day.